Hello everyone, welcome to my YouTube channel. So today I am going to discuss the Tifr Gs 2020 solution. First I will upload a video for MCQ section and then I will upload a video for true false section. Both video will come today. So let's start. The first problem. So I am following the official question paper. Okay, I will give you the website link here, or you can just search in Google the Tifr Gs past year exam papers. You will go to the official website and download that. I am following one by one the problem from the official question paper. Okay. So the question number first, please uh, please be ready with the question paper so that you can understand the question. Okay, I am not going to write the full question, then the video will be very lengthy. I'm just going to solve this problem. So an is 2 power n plus 3 power n whole power 1 by n, and bn equal to n by summation 1 by I equal to 1 to n. So observe that 3 power n is less equal to 2 power n plus 3 power n, less equal to 2 times 3 power n. Then you will have this 3 less equal to n less equal to 2 power 1 by n times 3. So take limit both side. So you will get by sandwich theorem n is 3. Right? Then limit n tends to infinity 1 by n is 1 by 3. Then by Cauchy's theorem, limit n goes to infinity 1 by a1 plus 1 by a2 plus 1 by n is 1 by 3, right? That means limit n tends to infinity 1 by bn, this is 1 by bn actually is 1 by 3. That will imply limit n goes to infinity bn is 3, right? So first question is done. Come to the second one. So f is a set of all continuous functions that satisfies 0 to 1 fx times 1 minus fx dx equal to 1 by 4. Okay, then we need to find the cardinality of f. Okay, so 0 to 1 fx minus fx square minus 1 by 4 dx equal to 0. In 0 to 1 fx square minus fx plus 1 by 4 dx is 0. Then we have 0 to 1 fx minus half whole square dx is 0. Now fx is a continuous function, that means fx minus half is also a continuous function and that square is also a continuous function. So if I replace gx equal to fx minus half square, then I can see that gx is always greater or equal to 0 for all x inside closed interval 0 1, and integration 0 to 1 gx dx equal to 0. And since gx is continuous and gx is greater or equal to 0, that will imply gx equal to 0. Then that will imply fx equal to half. So this is the only function. That means exactly one function exists. So option B correct. Okay. Go to the third one. So fx is given by x square sine 1 by x if x not equal to 0 and 0 if x equal to 0, right? x equal to 0. So clearly for x equal to 1 by n pi, f of 1 by n pi is 0. So that means set of all zeros is not a finite set, right? Not a finite set. Okay, what about derivative of f? Derivative of f is x plus x square cos 1 by x times minus 1 by x square. So clearly you can see that f dash is not continuous at 0, right? F dash is not continuous because these terms becomes cos 1 by x. So f dash is not continuous at 0. So C, D both are wrong. Now what about B and A? So observe, limit x goes to infinity, x sine 1 by x is 1. Why? Because we can write it as limit y goes to 0. We know that limit y goes to 0, sine 1 by y is 1. Right? Now replace y by 1 by x. That means x goes to infinity, sine 1 by x by 1 by x, which is x sine 1 by x equal to 1. Right? That means limit x goes to infinity, x square sine 1 by x is infinity. So clearly f is unbounded. Right? And this is continuous, so you can do it for x goes to negative infinity also, and you will see the sequence, one sequence such that it goes to negative infinity. So hence this is obvious that f is a surjective function because f is overall continuous, but it is not bounded. So it is easy. It's a very easy problem. So option A is correct. Problem number 4. Very important and very interesting problem. So an be a strictly increasing bounded sequence of real number such that n strictly increasing bounded. Then an is convergent. We know that by monotone convergence theorem. It is given to be a, and we have defined a function f from a1 to a to r, which is continuous, such that on each interval is either strictly increasing or decreasing. It is given, right? Or decreasing, strictly decreasing, right? Then we need to find out the cardinality of such set, right? So first of all, observe that if you take a1 to say an for some n, a1 to an, that means there are finitely many terms here, say an, right? And say let's draw it. Say this is a1, this is a2, this is a3, a4, say this is an. Okay, there are n many terms. Okay, n is a fixed number. Then each interval f is either strictly increasing or strictly decreasing. It may be happens something like this, then again this, then again this, or something like that. But you can observe that since any strictly increasing function, and if f is continuous, that means f is monotone on each interval, right? On each interval f is monotone. That means if for m is attained and xn is a sequence which is bounded inside this, not xn, I should write it as xm, because here n is fixed. Okay, n is fixed n. Okay, so if xm is a sequence which is bounded in between these finitely many terms of this sequence an, right, a1 to an, right, then f of xm, let any value m, can attain only finitely many times, because say m attained inside one, because on each interval on each interval interval a1 ai to ai plus 1, f is monotone. That means at most one value m can take from here. That means at most one x exists in each ai comma ai plus 1 such that fx equal to m, right? That means there doesn't exist infinitely many x such that f of x equal to m, right, from this sequence. So only thing can happen that xn is another sequence. So only thing can happen, that is, so only thing can happen that xn is a sequence such that xn goes to a, sorry, xn goes to a and f of xn is m for all, right? Because just draw the picture. Here see a1, a2, a3, a4 and so on, a5 and so on. Now we know that on every small subinterval there exists at most one xn. So if I want to have infinitely many x such that f of x is m, then I can take it as a sequence, say xn, that sequence such that each term goes to m. Okay, then one xn, I mean 2xn must be come from two different interval. Okay, that is the thing, because on each particular interval f is strictly monotone. I mean f is monotone, and since f is monotone, strictly monotone, that's why it is 1 1 on each sub interval, right? So that means xn has to be a sequence which converges to a and f of xn is m. If I take another m prime, say m prime be another element, then also if m prime be another element and there exist different infinitely many x such that f of x is m prime, then I can take that as a sequence yn such that yn goes to s and f of yn equal to m prime for all n. Now f is continuous. The interesting thing is that, interesting fact f is continuous at a. That means any sequence converges to a, f of xn must converges to f of a, right? That means if two different sequence converges to a, f of yn must be go to the same element, right? That means f of a has to be m. So m and m prime has to be equal. That means one thing that I understand, that if such exist, if such a point exists m such that there are infinitely many x such that fx equal to m, that means that m has to be f of a. That m, if such m exists, that means it cannot be greater than 1. So the cardinality is of b is less equal to 1. Okay, but it might happen that it is 0, right? It might happen it is 0. So here the option a says that it is necessarily 0, or option b says that at most 1. So I need to give an example where it is not 0, right? So take such a function, right? So I'm giving a function, okay, just geometrically define a function. Let's say this is 0 and this is something which is bounded, some sequence. Okay, say this is a1, say this is a2 and so on. I just draw it, okay, and say this is a. Okay, and do this. This is strictly increasing, strictly decreasing. This is strictly increasing, this is strictly decreasing, this is strictly increasing, so that at each term this height and this height must be half. That means if this height is L, then this height must be L by 2. I am defining in such a way. Again go this and go this, so that this height must be L by 4, and so on. Then if some m value is attained infinitely many times, that means what? That means if you draw a line, say it is m, that cuts infinitely many times of this from this graph, right? But I am already defining in such a way as each stage it gets half and half. So only value that can attain infinitely many times is 0 here, because f of 0, sorry, 0 equal to f of n for every n equal to odd, for every n odd. I am defining in such a way, right? That means 0 is exactly the one point which attains infinitely many times, right? So that's why it is not necessarily 0. The cardinality is not necessarily 0. That means it is at most 1. So option B is correct. Okay. Go to the next one. So problem number 5. This is an easy one. So mod fx minus fy is less equal to mod x minus y times sine x minus y. That means mod fx minus fy by mod x minus y less equal to sine x minus y. It's mod. Let x to be y plus h. So mod f of y plus h minus f of y by h is less equal to sine h mod. So limit h tends to 0. This is 0. That means f prime y is 0. Right? And this is true for any y. Right? That means f prime y is 0 for all y in R. This will imply f is constant. Problem number 6. So we can, the same type of problem I think I have already solved. This is this one, you can write it as fx by e power 2x by using L'Hopital. Fx to 2x, which is same as limit x tends to infinity f prime x plus 2fx p2. Now it is given that limit x tends to infinity 2fx plus f prime x is 0. That means it is 0. Hence limit x goes to infinity fx is 0. That means option B is correct. For any f belongs to this collection, this holds. So this is a general proof. Now problem number 7. So fx equal to log 2 plus x by root over 1 plus x for x greater or equal to 0. Then limit x tends to infinity fx equal to limit x tends to infinity log 2 plus x by root over 1 plus x, which is infinity 1 by 2 plus x times 2 root 1 by x, which is 0. That means limit is 0. Right? Now define a sequence bn equal to integral n minus 1 to n ft dt. Right? So mod bn less equal to, okay, so mod bn less equal to infimum of mod of ft t belongs to n comma n minus 1 comma n supremum of mod ft uh, t belongs to n minus 1 comma n, right? So that means since limit x goes to infinity fx is 0, this will imply that limit n tends to infinity bn is 0, because these both part as n goes to infinity this goes to 0, so this is 0, right? Bn is 0. Now an equal to b1 plus b2, am equal to b1 plus b2 up to bm by m. Why? Because b1 is 0 to 1 ft dt, b2 is 1 to 2 ft dt, and bm is m minus 1 to m ft dt by m, which is same as 0 to m ft dt by m. Okay, then by Cauchy's theorem, since bm goes to 0 as m goes to infinity, am also goes to 0, hence b is correct. Okay, this one is, so the last problem was easy if you know the technique. So f is a continuous function given such that this holds. That's right. So first of all, see that if fx equal to fy, then mod fx minus fy is 0. It will imply log 1 plus mod x minus y is 0, which implies that mod x minus y is 0, implies that x equal to y. So f is injective, and given that f is continuous, right? Given that f is continuous, so f is injective means f is strictly monotone. So either f is decreasing or f is increasing, right? Okay. Now fx minus fy log 1 plus mod x minus y, which is same as fx minus f0 greater or equal to log 1 plus mod x. Now say x goes to infinity. Okay. Since x goes to infinity, log 1 plus mod x also goes to infinity. That means from here I can say that f is continuous. So fx goes to infinity or negative infinity. So without laws of generality, you can assume that fx goes to infinity, say, okay, as x goes to infinity. Now when you take x goes to negative infinity, then fx has to go to negative infinity. It cannot go to positive infinity because f is strictly monotone. Okay, so either f is strictly increasing or f is strictly decreasing. So if fx goes to infinity as x goes to infinity, that means f is strictly increasing. That means fx has to go to negative infinity when x goes to negative infinity, and vice versa. Okay, so that means f, and since f is continuous, that means f attains every value in between this. So that means f is surjective. This implies f is surjective. This one is very easy. See, I am explaining all the questions. So if you have any doubt at any point, just mention the timing and comment. If you have any doubt, I will definitely answer. Okay. Okay. Go to the problem number 9. What is the greatest integer less than or equal to this? So see, n equal to 1 to 9999 1 by this. Okay. If you add 1 by, if you add say 1 by 10, so greatest integer less than or equal to this plus this, both are same, right? So I can just add it. So what will you get? I will get summation n equal to 1 to 10,000, 1 by power root n. Okay, and this is something, sorry, 1000, which is less than integral 1 to 10,000, 1 by 4 x to the power 1 by 4, sorry, 1 by x to the power 1 by, this is fourth root of n. Okay, not 4 root n, this is fourth root of n, this is fourth root of n. So this is x to the power 1 by 4 dx, and you will, if you solve this integral, you will get 1332. So that means option A is correct. Okay, problem number 10. For every connected subset y of a metric space X, its interior y naught is connected. This is obviously false. Take R2. Okay, so take R2. Say this is -1, this is 1. Okay, this is -2, this is 2. So take a circle like this, take a circle like this, take a disk, because interior means this full, and join these two by this straight line. Okay, so then what about interior? Interior is, this is, give this A and B, so interior of y is A union B, because interior doesn't contain any point from this part, right? That means this is clearly disconnected. You can see this is clearly disconnected here and here. This is clearly disconnected. And what about the boundary? For any connected subset y of a matrix with this boundary, take in R, take 0 1 as y. So boundary of y is this. This is clearly disconnected. Hence both are false. Okay. Question number 11 is a probability question. I am not interested to do it. You can just try or solve. Question number 12. If you can't understand question number 12, this is easy one. This is a computational problem, but if you can just do it for 3 or 4 and 5, and you can just understand why it is 2 plus 7 also. Okay, so you have to just plot it. So start from 1, say. Otherwise, if you start from anywhere, you can just rotate it, so that doesn't matter. Okay, that doesn't matter, because rotation takes every vertex to that angle. I mean, just anti-clockwise, it rotates that angle, so this doesn't matter. So you can start with 1. Okay, and say this is second one, second vertex, this is the third one, and so on. Okay, and you will get some polygon like this or something like this. Okay, some polygon something like this or any. So that means what will you get actually? So so here it is z1 z2 up to z7, right? That means z1 is 1, z2 is e power 2 pi by 7, z3 is e power 4 pi by 7, and so on. Z7 is e power 12 pi by 7. These are the vertex. Now you can just multiply z1, z2, z2, z3 is each to 1, right? And then the sum. This is easy fact to see that w is 0. You can prove it for 3, 4, and then generalize it also. Okay, I don't want to waste time here. This is a computational problem. Because problem number 13 is very interesting and very conceptual. Simple problem but conceptual problem. So R3 is a space of 3 cross 1 real matrix, and multiplicative group GL3R acts on this by scalar multiplication. That means you can take any V. Okay, you can take any matrix A. This acts on V as AV. This gives you AV. Okay, that is also a vector which is W, say. That means A acts on V and gives you W. That's the action. What is number of orbit? So see, if you take 0 vector and A is always from ZL3R, that means A of 0 is 0, that is true always because A is a linear map. And if A of V is 0, that will imply V is 0, since A belongs to ZL3R. A is invertible, so V cannot be non-zero. That means orbit of 0 is singleton, is 0 itself. Right? Now take any non-zero vector V. Okay, take any non-zero vector V. Any two non-zero vector V and W. Okay. Now define a map V to W. Extend V as a basis of R3, say V prime and V double prime, and extend W as a basis of R3, say W prime and W double prime, and define a linear map, say V goes to W, V prime goes to W prime, and V double prime goes to W, V double prime goes to W double prime. So you will get this linear map, and you take the matrix representation for that linear map with respect to this basis, say B, okay, B prime, okay. Then clearly V goes to W, V prime goes to W prime, and V double prime goes to W prime. And this matrix, this map is invertible because this sends every basis element three linearly independent elements to three linearly independent elements, because this is also a basis as well as this is also a basis. I'm doing in such a way. I'm just extending the singleton V and singleton W as a basis of R3. So you can always find so if you take any V and W, you can always construct a matrix A such that AV equal to W. That means any two non-zero vector in the same orbit. That means exactly two orbit exist. Exactly two orbit. One is the singleton orbit 0 and another one is set of all non-zero vectors. So exactly two orbit exist. Singleton 0 and set of all non-zero vectors. What about question number 14? So V is a finite dimensional vector space over R and W subspace of V. Then for every linear automorphism, V to V, linear isomorphism, W intersection T of W is non-empty. That means okay, then I need to show that dimension of W is greater than half times dimension V. We need to show dimension of W is greater than half times dimension of V. So if not, say dimension of W less equal to half times dimension of V. Okay. Okay. Now take a basis of W. Say W1, W2 up to WK. Okay. And extend this basis to a basis of V. Okay. Say W1, W2 up to WK is already there, plus say add V1, V2, VK, plus if it is exactly half, then it is just up to VK, or there may be some VK plus 1 up to VK plus L. Right? This is the basis. Now I am going to define a map T from V to V, where I send W1 to V1, W2 to V2, WK to VK. Okay, and V1 to W1 up to VK to WK, and if there is any extra, I just map it identically. So VK plus I goes to VK plus I for I greater than equal to 1 less than equal to L, if anything is extra. Right? Now W is span of W1, W2 up to WK, right? And T of W is span of v1, v2 up to vk, right? These are linearly independent because they forms a basis. That means w intersection tw is just singleton. So that means it if it is less equal to half times dimension of v, then I can always construct a linear automorphism t from v to v such that w intersection tw is trivial. Hence this cannot be possible. That's why dimension of w is greater than half times dimension of v. Fine. Problem number 15, right? So we have B, which is block diagonal matrix. Okay, AA0A is diagonalizable if and only if A is 0. I need to show that, right? So if A is 0, then it is clearly diagonalizable. Okay. If A is 0, then B becomes 0, 0, 0, 0. That is a 0 matrix. That means it is diagonalizable. If A is non-zero, so observe that B power n is basically A power n, n times A power n, 0, A power n. Okay, B power n is this. So before going to that, I just first let me do. So we know that a matrix is diagonalizable if and only if the minimal polynomial has no repeated root. Okay, so I'm going to check the minimal polynomial for B, right? See, minimal polynomial for A, let's say PA of x, then it is easy to check. It is easy to check that minimal polynomial for B, that is PBX, must divide PAX square, because A is this, right? So minimal polynomial for A is PAX, this is PAX, that means minimal polynomial for B must divide this, right? Must divide this. Okay. So now if B is diagonalizable, then what can we say about this? It is PAX square. Okay. What can we say about this? Can it be possible if A is non-zero? Now see, minimal polynomial for B cannot be PAX. Why? Because say let PAX is A0 plus A1x plus AKX to the K, right? Then PB of PA of B is basically same as A0 plus A1B plus AK B power K, which is same as A0 plus A0 identity plus A1A plus AK A power K, A0 identity plus A1A plus 2A2A square plus KAK A power K 0, and A0 identity plus A1A plus AK A power K. So this is 0, but this is non-zero. This is something, some C, this is 0, this is 0. Because that is the minimal polynomial, right? So that means minimal polynomial for B is not PAX unless it is 0. So I'm assuming that A is non-zero matrix. Okay, I'm assuming that A is non-zero matrix. Then minimal polynomial for PBX is not equal to PAX. But PBX divides PAX square. That means, and it is not PAX. That means there is some factor of PAX which occurs 2 times in PBX. So there is some factor of PAX occurs 2 times in PBX. But it is given that B is diagonalizable, which is not possible. That's why it is a contradiction. Hence, whenever A is non-zero, this is not diagonalizable. That's why B is diagonalizable if and only if A is 0. Okay, this is the thing. Go to the next one. Question number 16. T from C to R, define that Tz equal to Z plus Z bar. It's a C vector space and this thing, right? So you can just take, say, Fz equal to U plus IV. Okay, since I should IV for X belongs to capital V, it is the vector space. Okay, and if we write it as U plus IV, where U is the real part, V is the imaginary part. That means T compose F and say G equal to U prime plus IV prime. T compose F equal to T compose Z means U plus IV equal to, sorry, 2U equal to 2U prime. Because T is Z plus Z bar, that means 2U prime. That means U equal to U prime. Right? Now F is C linear. That means F of IZ is I times F of Z. Right? That means F of IZ is IU minus V. So for that particular Z, minus V is same as minus V prime. Right? That means U equal to U prime as well as V has to be equal to V prime. That means F is injective. F is injective, clearly. Clearly F is injective. Now suppose we need to show that this is surjective. So let G from V to R be a R linear map. Okay, I am define G tilde from V to C where Z tilde of IZ equal to I times Z of Z. I am defining in this way. Okay, that means, so that means the actual map is, say, Z tilde of any V is I times Z of Z. Okay, basically I am trying to extend the scalar. I am defining in this way. That means when it is, that means itself, when I am take not I should take it as C times ZZ for C belongs to complex number. I am extending the scalar. So that means if C belongs to real number, then Z tilde is Z, right? Not, sorry, Z tilde is Z by 2. I define it as by 2 that I require. Okay. So that means Z tilde of CZ is C times ZZ by 2. Clearly Z tilde is a C linear. Z tilde is C linear from the definition of Z itself. Now my claim that T compose Z tilde is Z actually. Okay. That means T compose Z tilde same as Z tilde plus Z tilde bar. Okay. Which is same as Z by 2 plus Z by 2, which is C. That is easy to check. You can easily check this. Okay. So that means given our linear map, I'm extending that linear map by defining in this way, that I define another map z tilde from V to C such that z tilde of Cz, where C belongs to any complex number, is C times C times Cz by 2. I'm defining it this way. Okay. Then we will get this is also a linear and this maps to this. So that means this is a bijective map. Question number 17 is very easy. Question number 17. T cube minus t square minus t plus this is 0. That means t square into t minus I minus 1 times t minus I. So that means t minus I squared times t plus I is 0. That means I can take a matrix as that the minimal polynomial is this polynomial. Choose a matrix, choose T such that minimal polynomial is this. That means it is clearly not diagonalizable because minimal polynomial has repeated root, and it is invertible always because 0 is not an eigenvalue. So it is invertible but not necessarily diagonalizable. It's a very easiest question here. Okay, problem number 18. So let n greater or equal to 2. Which of the following is true for n by n matrix of rank 1? So first see rank of A is 1. That means eigenvalues of A is 0 0 0. I mean all eigenvalues are 0. That means say A is nilpotent, one case. And another one is that eigenvalue of A is say lambda 0 0 0. This one. Okay. These are the two cases. So in particular, first say I can take this matrix 0 1 0 and all the other rows are 0. This is the upper triangular matrix, so that means all eigenvalues here 0 because these are upper triangular matrix, so diagonal entries are eigenvalues, all eigenvalues are 0, but this matrix has rank 1. So C and D both are false, and 1 1 1 1 1, this is not an eigenvector clearly. So C D false. Also there it says that A is necessarily diagonalizable. That is not true because if all the eigenvalues are 0, then algebraic multiplicity of 0 is n, but since rank is 1, that means geometric multiplicity of 0 is n minus 1. Since they are not equal, and clearly this matrix, you can take particularly this matrix is not diagonalizable because already it is in its Jordan form. Okay, and you can see that this is not diagonal, so this is not diagonalizable. Fine. So B, C, D are false actually. So only left option is A. So A is correct. But I want to explain it more, that why this statement is true. Okay. So it says that there exist P and Q such that all entries of this matrix PAQ is equal to 1. So first see that so you can write A to be PJ P inverse. Okay. You can write it A to be PJ P inverse, where A is the Jordan form. Jordan canonical form of A. Okay, you can write it. Okay, PJP inverse. It is better not to write P here because P is already mentioned there. So I said SJS inverse. Okay, then PAQ is PSJ S inverse Q. Right? So that means say this PS is some TJ and it is say R. Right? Okay, so if I can write any Jordan form corresponding to the matrix such that there exist two matrix T and R such that TJR has all entries 1, then we are done because I can take T to be PS and R to be S inverse Q, then PAQ is same as TJR, then all the entries of PAQ is 1. So it is enough to take a Jordan canonical form for possible Jordan canonical form in this context, and then show that there exists two matrix T and R such that all entries are this. Okay. Now one thing is important, that is uh, since A has rank 1, J cannot be zero matrix, right? Because A is zero matrix means A itself is zero matrix, right? This is not possible because A has rank 1. So A has rank 1. So what is the possible Jordan form? The possible Jordan form is, say lambda, say it is the diagonal matrix, 0 0 0 0 0. Okay, and so only except one entries all are 0, right? So if you multiply it by some matrix, and say b11 b12 b1n bnn, what will you get? So from by just multiply first two matrix, here is exactly one entry is lambda, all the other entries are 0, and lambda is non-zero. Okay, so then you will get this 0 lambda a21, all the entries are 0, lambda a n1, all the entries are 0, and here you will get b11 b12 b1n bnn, and this bn1 to bnn. Just computation, you can see it easily. Okay, what will you get? 11 b11 lambda a11 b12 lambda a11 b1n lambda a n1 b11 to lambda a n1 bnn. Now take this matrix to be all entries 1 by lambda and this matrix to be all entries 1. Then this entries becomes 1, all the entries becomes 1. So this is a matrix which says that all the entries are 1. So you take this matrix B, so you take this is C1, so you just take this one, Bij is 1 for all ij, and take Aij is 1 by lambda for all ij. Then we will get this matrix that all entries are 1. And similarly, if there is another Jordan form, that means all the eigenvalues are 0, and all the eigenvalues are 0 and rank is 1, that means A is not diagonalizable. That means exactly two block corresponding to 0 eigenvalue and all the others are 0. That means the Jordan form looks like this. All the 0, this is 0, this is 0, this. You can easily check that if Aij equal to 1 for all ij and Bij equal to 1 for all ij, if you multiply this matrix, then you will get a matrix where all entries are 1. Okay. Hence we are done. So this is a correct statement. Okay. You can just solve. In exam hall, you can just discard other 3 options, which is quite easy, and give this one is the correct answer. But theoretically, this is possible, and that because of by using Jordan canonical form. Okay. 9. So mn be a positive integer, greatest common divisor GCD of x to the power m minus 1 and x to the power n minus 1. See, x to the power m minus 1, the solutions, roots are mth root of unity, and roots are nth root of unity. And common factor means what are the common roots? First find the common roots. First find the common roots. The common roots lambda I, and then product of x minus lambda I. That will gives you the answer, right? Now mth root of unity and nth root of unity. So how many roots are there? So roots of mth root of unity, that forms a subgroup. Roots of nth root of unity, that forms a subgroup. So what is the unique subgroup? That is cyclic also, both are. So what is the unique subgroup is there? That's already GCD, right? So clearly it is easy to check, or you can take some two values and see that why this is true. That is quite easy, that x to the power GCD of mn minus 1 is the greatest divisor. It's easy. It's simple to check. And then problem number 20 is also easy. The A4 is a group of even permutation. There is a surjective group homomorphism from A4 to this. Right? That means A4 to Z4. If there is surjective, that means kernel has order 3. Right? Kernel has order 3. Is it possible in A4? You know the elements of A4. And that then check. It is not possible. Definitely, it's not possible. But the second thing is possible, because the normal subgroup of A4 is K4. K4 is a normal subgroup of A4. So you can just take that normal subgroup and define a map. Then A4 mod K4 is isomorphic to Z3. Okay, and that is the surjective group homomorphism. Surjective group homomorphism. It is a simple fact. That means B is true. Okay, these are the part 1 solution. Entire MCQ section I will upload true false section soon. Okay, thank you.